So we're going to look at resistors in series. And I think the main thing is that if you look at this example here, so think about two resistors here. So this is my body. It's connected to, so this is my R1 and this is my R2. Again, the key point is that for resistors in series, the current must be the same, so I1 must be equal to I2, which is you see in this equation right here. So the total current is equal to I1, which is equal to I2. Because the same amount of current that goes through resistor number 1 is the same amount of current that goes through resistor number 2. So the current is the same. The current is the same, but the voltage is not the same. So for example, if you calculate the voltage across R1 and the voltage across R2, then it means that the total voltage, delta V, must be equal to delta V1 plus delta V2. Now, if you rearrange this equation here, because I1 is equal to I2, you can write this as I1 into R1 plus R2, which, because I1 again is equal to my I, so this is just I into R1 plus R2. And so this tells me that my R equivalent is equal to R1 plus R2. So this is different from capacitors, right? If you remember for capacitors, when you connect two capacitors in series, the combined effect is not just C1 plus C2, but you calculate it using 1 over C equivalent is equal to 1 over C1 plus 1 over C2. Now, finally here, so if the resistors are in parallel, now in parallel, the voltages are the same, but the currents are not the same because so for example, the total current coming in here, whatever current comes here is going to branch into two parts. So there is a branching here, so this is called I1 and I2, so it means that the currents are not the same, but the voltages are the same. And so if you do this calculation, you should end up with something like this. Now, with this in mind, let me make one table here. And this table is going to serve as a summary that you can use. So let me stop my sharing here, and then I want to open, so stop share, open this. So let me share this screen here. So let's do a quick summary here. So I'm going to draw 4 boxes here. The first box is going to have a power supply connected to 2 capacitors in series. So call this delta V, call this C1, call this C2. So if 2 capacitors are in series, then you calculate the equivalent. So here, the charge in capacitor number 1 is equal to the charge in capacitor number 2, which is just equal to the total charge. The voltage across capacitor number 1 was the voltage across capacitor number 2. And we calculate the equivalent capacitance, so 1 over C equivalent is equals to 1 over C1 plus 1 over C2. Now, if I have two capacitors connected in parallel, so again, this is my delta V, this is my C1, this is my C2. When two capacitors are connected in parallel, then Q1 plus Q2 must be equal to Q total. And in this case, my delta V1 is equal to my delta V2, which is equal to my delta V. So voltage is the same. And then you calculate C equivalent as C1 plus C2. Now let's just do this real quick here. So now if you have two resistors, so R1 and R2 connected to a body, then my R equivalent is equal to R1 plus R2. The voltage across resistor number 1 plus the voltage across resistor number 2 must be equal to delta V. And in this case, notice that the current through resistor number 1 is equal to the current through resistor number 2, which is just the current I. Now, if you have two resistors connected in parallel, this is my delta V, this is my R1, this is my R2. Now, notice that this point here, this point, so this point here is called a branch. It's a branch. Because this point is a branch, it means that whenever the current comes in here, I, is going to split up into two parts. One part is going to be called I1, and one part is going to be called I2. So it means that in parallel, I calculate 1 over R equivalent is equals to 1 over R1 plus 1 over R2. Delta V1 is equals to delta V2 is equals to delta V, and I is equals to I1 plus I2, where I is the total current. So I want you to have this table. We're going to look at this next class. We'll take this and solve a few more problems, but you should have this table to understand the connection between series connection for capacitors and series connection for resistors, series connections for parallel connections for capacitors and parallel connections for resistors.